This is what a typical microscale setup looks like. I have my pickle juice in that beaker, and I have 3 pipettes. One that's filled with 0.25 molar sodium hydroxide, another pipette with phenolphthalein indicator, and the third with the pickle juice. I also have a stirrer which is made from the tip of a straight stem pipette, and so that I'm going to use for stirring. What I'm going to do is I'm going to put my pickle juice pipette into the holder, and the reason that I use that, so we're going to add some of the pickle juice, and I'm going to count drops. Having counted drops carefully, I will then remove the pickle juice from the well holder. And now I'm going to add some phenolphthalein to that, marked PTH, my abbreviation for phenolphthalein. And then I'm going to turn the microtip pipette very slightly downhill, because I know that phenolphthalein comes out of the microtip pipette very quickly. So I add a drop or two of that, and then I'm going to titrate with the sodium hydroxide to a phenolphthalein endpoint, and holding that pipette vertically, I'm going to add dropwise, and I'm going to titrate to a phenolphthalein endpoint. And after addition, I'm going to stir. You notice that after the addition of a certain number of drops, looks as if I'm at the end point, but the color doesn't remain. So I'm going to add another set of drops. Stirring at this point, the color of the phenolphthalein indicator does not go back to colorless. Remember, it's colorless, not clear. And so that's my endpoint. So I know the number of drops of the pickle juice I used. I know the number of drops of the sodium hydroxide I used. I know the molarity of the sodium hydroxide. The only thing that I don't know then is the molarity of the vinegar or acetic acid that I'm titrating in the pickle juice. And that calculation then can be done to calculate the concentration of the acetic acid in the